Imagine if someone pushed you off a swing when you were at the top of your arc. You'd probably just fall straight down and then keep falling until you hit the ground. But instead of you being a person and the ground being the Earth's surface, what if it was a massive wall of water instead? That sudden drop in elevation causes the energy to radiate outward in all directions like ripples on a pond. This sudden displacement of water forms ocean waves that we call tsunamis. Tsunamis can be caused by underwater earthquakes, volcanic eruptions, or landslides. They have also been known to be triggered by meteorite impacts. But meteorite impacts are pretty rare, so let's focus on the other three for now. Earthquakes are the most common cause of tsunamis because the ocean bottom is constantly shifting due to tectonic plate movement. When the plates suddenly slip past each other, it causes a large amount of energy to be released. If this happens underwater, the energy is transferred to the water column, causing a tsunami. Volcanic eruptions can also cause tsunamis either by the explosion itself or by the collapse of a volcanic island, which displaces a huge volume of water. Landslides in or near water can also trigger tsunamis by pushing a big chunk of earth, rock, or debris into a lake or ocean and displacing a large amount of water. Sometimes there's no warning at all before a landslide occurs. Even if there is some warning, there may not be enough time to take cover if the landslide is fast enough. So how can we predict when a tsunami might happen so that people can get out of the danger zone in time? Well, one way is to monitor seismic activity around the world. Earthquakes that occur under the sea can be detected by a network of sensors called a tsunami warning system. These sensors are called buoys, and they float on the surface of the water while recording data. Each buoy has a seismometer attached to the seafloor and a pressure sensor connected to the seafloor by a cable. When an earthquake happens underwater, the seafloor vibrates and the pressure in the water changes. By measuring these changes, the buoy can calculate the magnitude and timing of the earthquake. Buoys can also measure wave activity, including the size and speed of tsunami waves. If the buoy detects a potential tsunami, it sends a signal to a tsunami warning center. The center uses complex computer models to calculate the size and timing of any potential wave activity that could impact land. Then they issue a tsunami warning or an all-clear message based on their predictions. Indonesia sits on the infamous Pacific Ring of Fire, an area where tectonic plates collide and cause frequent earthquakes and volcanic eruptions. On December 26, 2004, a 7.6 magnitude earthquake struck off the coast of Sumatra Island. People felt the ground shake for up to 3 minutes. That's a long time. The quake triggered a series of tsunamis, some of which were over 100 feet high. In total, the waves affected 14 countries and killed over 220,000 people. It was the deadliest tsunami in recorded history. In December 2018, an earthquake with a moment magnitude of 7.5 struck just off the coast of Sulawesi Island, triggering a small tsunami. However, this event had a smaller death toll. Only 426 people lost their lives. Why? Well, scientists think the death toll was much lower because this tsunami was a backward or retrograde tsunami. Regular tsunamis move away from their source, but retrograde tsunamis move back towards their source. A lot of the damage in Indonesia is done by the waves moving away from the epicenter of the earthquake. So having the waves go back towards the epicenter means less damage overall. Not all tsunamis are created equal. They're classified according to their height. Small ones are less than 1 meter tall, medium ones are between 1 and 3 meters tall, and large ones are over 3 meters tall. As you would expect, larger waves cause much more destruction. A small tsunami could maybe just cause some minor flooding, but a large tsunami can cause catastrophic damage. If a large tsunami is headed your way, you should get to higher ground as quickly as possible. Ideally, you'll have a few minutes to prepare, but sometimes you'll only have seconds. If you find yourself caught in a tsunami, protect your head and try to stay afloat. If you're outside, protect your head and try to stay afloat. If you're driving, park your car and run to higher ground. If you're at home, try to move to the highest floor and stay away from windows. Just remember to stay calm and follow the advice of local officials. Most of us live far from giant wave country, so our chances of experiencing a tsunami are pretty low, but that doesn't mean they never happen. In March 2011, a 9.0 magnitude earthquake struck off the coast of Japan. The quake was so powerful that it changed the location of some islands and pushed others under the sea. This was the most powerful earthquake in Japanese history, and it triggered a devastating tsunami. Waves over 100 feet high crashed into Japan's eastern coast, inundating coastal communities. Over 150,000 people had to be evacuated, and thousands of buildings were destroyed. Unfortunately, the nuclear power plant near the coast lost power, which led to a meltdown and explosions. More than 15,000 people lost their lives. The Tohoku tsunami was one of the most expensive disasters in history, with damages totaling over $235 billion US. After the disaster, Japan worked hard to improve its tsunami warning system. Before the tsunami, only about 30% of the population in the most dangerous areas received an evacuation order. But after the disaster, this number increased to over 80%. But what if there was a way to protect coastal communities from tsunamis without issuing any warnings? Meet the S-wave, a mechanical wave designed to absorb the energy of tsunami waves and dissipate them harmlessly. Essentially, the seawall acts like a sponge, soaking up the energy of a tsunami and protecting coastal areas from damage. But how does it actually work? Well, let me show you. Here's a regular wave approaching a coastline. Without any wave-absorbing structures, the wave will simply crash onto the shore and cause erosion and flooding. But if we add a seawall to the equation, things change dramatically. Now when a wave hits the seawall, most of the wave's energy is absorbed by the structure and dissipated through friction and converted to heat. This means that instead of crashing ashore, the wave is significantly weakened and can't cause any damage. So it's like a shield that protects the coastline from the destructive power of the waves. In fact, the seawall has been around since 2009. It's been tested against many different kinds of waves and has proven to be very effective. It was even tested against the 2011 tsunami and was able to withstand the force of the waves. And unlike evacuation orders, the seawall doesn't need to wait for a tsunami to be detected. It can be deployed immediately, giving coastal communities added protection against surprise attacks. But as impressive as the seawall is, it won't work against every single kind of wave. For example, a lava tsunami, which is caused by a volcanic eruption, has a very different shape than a regular tsunami. Because of this, the seawall may not be able to absorb all of its energy, which could lead to some damage. So scientists are working on new ways to protect coastal communities from all kinds of tsunamis. One idea is to use a breakwater, which is a structure built offshore to absorb wave energy before it reaches the coast. Another idea is to build a series of smaller breakwaters that create a barrier between the ocean and the coast. There's even an idea floating around to use floating breakwaters that can be moved around to protect different areas of the coast. By exploring these and other options, scientists hope to find new ways to protect coastal communities from the destructive power of the waves. No matter what type of tsunami it is, one thing is for sure, it's important to take steps to stay safe. Most of the time, tsunami waves don't actually hit the same place that the earthquake happens. Instead, they travel across the ocean and can strike hundreds of kilometers away. That's why it's important to know the risks and take the necessary precautions. You can find out if you live in a tsunami risk zone by checking with your local authorities or looking at a map of your area. If you do live in a high-risk zone, it's important to make a plan and practice it with your family. Know where to go and what to do in case of an emergency. Having a plan can help keep everyone safe and reduce panic in a stressful situation. One of the best ways to get early warning of a tsunami is to sign up for a tsunami alert system in your area. These systems typically send messages to phones and other devices when a tsunami is detected. Another good idea is to install a tsunami monitoring app on your phone. Some apps can even provide real-time updates on the size and location of a tsunami wave. Of course, it's also important to be aware of the signs of a tsunami. If you see the ocean suddenly recede, that could be a sign that a tsunami is coming. Also, if you feel a strong earthquake, a tsunami could be on its way. If you notice any of these signs, you should head to higher ground as quickly as possible. Being prepared can make all the difference in staying safe during a tsunami. It's important to take steps to protect yourself and your loved ones. So make sure to learn about the risks in your area and take the necessary precautions. Thanks for watching. If you want to learn more about strange facts, stay tuned for more updates. See you next time.